Hi everyone, in this video we're looking at measures of center. So as an example, I want to look at a really small data set. These are some ages in a class. So ages of people, we have 19, 20, 20, 21, and 28. And the question that we're trying to answer when we're talking about measures of center is essentially what is the average age in the class? And we try not to use the term average in statistics because average can be measured in a bunch of different ways. What you might be used to seeing as the average is what's called the mean. This is the arithmetic average, or this is the arithmetic mean that we're calculating here. This is where we take each of those ages, add them up, so 19 plus 20 plus 20 plus 21 plus 26, and divide by how many ages we have, in this case 5. So if I take all those and add them up, I get 106, and then I divide by 5. This gives me 21.2 years. This is the mean of this data set. It's giving us a type of average. And the way you can think about the mean is, imagine we took these ages and kind of plotted them as a dot plot on a number line. So we have a dot here at 19, one at 20, another at 20, one at 21, and then one over here at 26. If you imagine these as actual objects on the number line, the arithmetic average is actually the balance point on that number line. So 21.6 would be right about here. This is saying that if these little dots represented kind of masses on that number line, the balance point would be right at this kind of fulcrum in the middle. You'll notice that in this case, most of the ages are actually below the mean. 4 out of the 5 ages are less than 21.6 years. But because that fifth age, 26, is quite a bit higher than the other ages, the balance point is going to be kind of shifted more towards the 26. And this is typical of a mean. Another common measure of center is the median. So the median is the number at the center of the list when the data values are in order. So in this case, this is easy to determine visually. If I have 5 numbers in the middle, we would have the number 20. 20 is the median of this data set. If you do have an even number of values, you want to take halfway in between the two middle numbers. But in practice, we won't be finding means and medians by hand very much. We will use Excel to do that, and I'll show you what those Excel functions look like in just a minute. But I do want to take a moment to contrast the mean versus the median. These are both ways to measure the center or the average of this data, but they're representing slightly different versions of that center. So the mean in particular is strongly affected by outliers or skew in the data, versus the median is not affected by outliers. And a good way to visualize this is by imagining taking this 26, which was already maybe an outlier. It's quite a bit higher than the other data values. And what if we made it much higher? So if that oldest person in the class, rather than being 26, was actually 40, well, this is going to increase my mean because the total of all of these numbers is quite a bit higher. In this case, this comes out to 24. But the median is not affected because the middle number is still 20. So this is an example of how these outliers or kind of skews, extremely high or extremely low values, can shift our mean sometimes significantly, but they don't shift the median. If your data set is symmetric, which this one is not, then the mean will always equal the median for perfectly symmetric data. In contrast, if we have a skew right, meaning a bigger right tail, that would look something like this, where in a histogram we would have most of our data towards the left and some data is kind of spread out towards the right. This would mean that the mean is higher than the median. So the median would be more closer toward the peak. The mean would get pulled further towards the tail. Skew left will just be the reverse. So if the tail is pointing to the left, that would mean that the mean will be smaller than the median. If you have outliers in both directions, that won't actually affect the mean. So when we say that the mean is affected by outliers, it's affected by outliers in one direction or the other based on the skew. One last type of average that we'll talk about here that's less common but can sometimes be helpful is the mode. So the mode is the most common value. If you think about the term a la mode, that usually means in the US with ice cream, like a pie a la mode. But a la mode means sort of like in the fashion of the day or as is popular. So I think of the mode as the most popular value, the one that shows up the most. In this small class, the mode would be 20 because there's 2 people with age 20 and everybody else, all the other ages, only show up once. Not all data sets have a mode. If all of the values have the same frequency, there will be no mode. Or if there are multiple values that have the same highest frequency, then there can be multiple modes. Modes are really only useful in discrete data. If you have continuous data, you're likely not going to see values with high frequency. And also when there aren't a ton of possible values. So for example, if you were looking at shoe sizes only come in a few different categories, and so we might look at, which shoe size is the most common. That might be important for ordering shoes if you run a shoe store or something like that. I do want to look at a real data set here, and in this case I'm looking at immunization rates from Colorado schools and child care centers. This data is from the Colorado Department of Public Health and Environment, and I'll put a link in the description. This is a histogram I made of the data in a previous video, and we can kind of visually estimate the center of this data set at roughly around 90%. This is, again, thinking about maybe the balance point or the middle number if I was able to list all these out, the mean or median. I'm not going to look at the mode for this data set though, because this is in fact continuous data, and if I look at the actual data values, let me pull them up, we have all of these percentages. It's really not likely that we're going to have 2 schools with the exact same percentage. And if we did, that would be more of a coincidence than anything meaningful. So the mode doesn't really make sense for this data set. So when I'm looking at this distribution, I get some sense of the center looking at the histogram, but really I want to kind of measure what is the average immunization rate for the MMR vaccine among Colorado schools. To compute the mean in Excel, I can use this function called average. So equals average, parentheses, and then I just put in my data values. So here's what this looks like. I make a little spot here for the mean. Next to this, I'm going to do equals, type in average, parentheses, and then I'm just going to highlight this whole column. You can highlight a certain range of values if that makes sense for your data, but in this case I'm going to click the K above my column because it's quite a long data set, and that will highlight the entire column of values. This function will ignore my label value %. So this gives me a mean of 91.06652. These are percentages, so I'm thinking of this as essentially 91%. Because this data has 2 decimal places, the standard would be to round this to 3 decimal places. If I come to my home ribbon and the number tab, I can adjust the number of decimal places to the appropriate value. So 91.067% is the average number of, or average percentage vaccinated among all the different schools. That average was looking at the mean. I can also compute the median in Excel, and that function is equals median. Same thing I would put in the data values. So down here next to the median, I will do equals median, parentheses, and then I'm going to highlight my column again. And there is my median. Again, these are percentages. Your median typically should have the same number of decimal points as the data, although sometimes you might have 1 extra if it fell in between 2 values. So 94.33%. So in particular, the fact that the median of this data set, 94, is higher than the mean means that this distribution has a skew to it. If it was perfectly symmetric, the mean and the median would be the same. what I'm visualizing here is a skew to the left, right, where more of the values are on the high end. That's representing the median, kind of where the bulk of the data is. And the mean is a little bit lower because it's being pulled lower by some lower outliers. And this is reflected in the histogram we were looking at earlier. We can see clearly in the histogram that the peak is towards the right, towards around 90%, and then we have some frequencies that get really, really, really tiny, all the way down to 0% vaccination rate with a fairly strong left skew. You might sometimes see that for skewed data, we prefer to use the median over the mean. In some cases, that is the case. The median here is going to be more of a typical value. So if I think of the typical school vaccination rate, that's going to be more around 94%. That mean being pulled down means that it's being affected by more extreme values, but the mean is still a significant value here. It's still an important point to note that while most vaccination rates are a little higher, around 94%, the average overall does include some of those low vaccination rate schools. And those are still important parts of the data. So you don't always want to exclude those that skew or those outliers because they can be relevant. It's important to note that both the mean and the median are representations of our data. To compute the mode in Excel, if there's only one mode, we can use this function equals MODE.SNGL, that stands for single, and then we highlight our data values. If I test this out on that MMR vaccine data, equals MODE.SNGL, and highlight those percentages, it turns out, actually, I was incorrect before. There is a mode here. The mode is 100, which actually makes a lot of sense because there are a number of schools where all of the students, for example, this one here, the percentage vaccinated is 100, and there's only 5 students in the school. So it's fairly easy to get 100% vaccination with such a small number of people. So this mode, this is the most common value out of this data set, 100. If you want to find multiple modes, we need what's called an array function in Excel. You may or may not be doing this in your class. Mode is not a super common calculation for statistics. As long as you have Microsoft 365 or Excel 2021 or newer versions, these are actually pretty easy to compute now. In older versions, there's a little bit different procedure for this. So here's my multiple mode example. In this case, because the data set is so small, I can visually see the frequencies that are highest. So I can see in the list that there were 3 4s and also 3 8s. All of the other data values show up only once. So I expect to see 2 modes here. But in many cases, you wouldn't already know what your mode is. So for the multiple mode calculation, I do equals MODE.MULT, put a parentheses, and then highlight my data. And this is going to give me an array, meaning it's going to spit out multiple cells rather than just filling in one value. And this lists my modes as 4 and 8. If you do have an older version of Excel, the way you need to compute this array function is to highlight multiple cells all at once. While they're all highlighted, type in your formula, so equals MODE.MULT, parentheses, and then highlight your data just the same way. And then instead of pressing Enter, you need to do Control-Shift-Enter, so all those keys all at once, and then it fills in the cells. If you try it the other way on older versions, it won't work. But as long as you have 365, you don't need to do anything fancy. Both of these versions are doing the same thing. It's just creating an array, a list of cells to put those modes in. That's all of our measures for center that we're looking at in this video. Thanks for watching.